Hi, this is Team 30, and we are working on the BraiNet project. And so our current progress is that we've completed all of the tasks that we needed to do. So for phase 1, it was creating the UI for the application, essentially. So the first task was to create a UI for username and brainwave signal. And to do that, I will show you how the application works. So this is the login screen, so a user can enter in their user ID. And then since we don't actually have the BraiNet hardware, we opted to just allow a user to put in a name, and it'll search the phone for that user's brainwave signal to be used as a way to verify the user ID against their brainwave data. So we press login, and it takes some time. And then once this appears, it asks the user to relax so that the phone can accurately identify the person. And then if the brainwave data matches the user that's trying to log in, then it'll show a success screen. But otherwise, it will show a fail screen. So that's the first task. And so the second task is getting the brainwave signal information from SD card for input. So what's actually happening is that since we don't have any brainwave data to be collected from the actual hardware, we had to put the data into the SD card ourselves. So when I go to the files on my phone, and I go to a folder called user brain data. This here stores all the brainwave data of a user in EDF form, which is European data format. And so over here on the code, what happens is that we have a part of code where it goes to that specific directory, user brain data, and then it finds all the files that have the persons that they're looking for their brain data. User inputs 1. So in our case, for our initial run, we did Bill, so it'll look for all files with Bill. And then since we assume that every person will only have one set of brainwave data on the phone, we know that it'll only bring up 1, so we just take the first index of the array, and that's it. Okay, so that's how it gets the brainwave information from the SD card. So testing the UI. So earlier I showed you a good run, but now I will show you a bad run. So let's put in Jen, and let's put in Bill. Or Jen for the user ID, and Bill for the brain data. And so it failed because we tried to use the user ID Jen, but the person that was actually trying to authenticate was Bill, because we're trying to use Bill's brain data. And so it also works for users that don't exist. So let's put in a guy named Nick, and let's try to log him in as Phil. So this is Phil logging in, but he's using the wrong user ID. He's using the user ID Nick. And it failed because he doesn't exist. So the next step is the remote server setup. And so our remote server is currently being hosted on our teammate's computer elsewhere. So as of the moment, what I'm about to show you is our fog server, which uses the same exact tools as our remote server, because they're both implemented the same exact way, but they're just on 2 different networks, where the fog is on our current network and the remote is on a different network, but they use the same exact stuff. So the tool that we use is examp. So XAMPP's a tool that helps start an Apache server, and it handles everything for us. So it actually has all the configurations for an Apache server. It has HTTPD configuration, all of the other ones, and php.ini. So it handles everything for us, so it's okay. So the next step in the next part of phase 2 is the database setup and connection. So there was no database that was used actually, so all the user's brain data is actually stored on the server. So here is our exam folder, has everything. So for the HTTP docs, and I go to BraiNet, and I go to brain data, this is where all the data is, or brain data is stored on the server, and this data is used as verification or authentication. And so this is where all the data is being stored. And so we had to create a pipeline to store and query the data. So we needed a way to authenticate the user. And so what happens is that when we type in a bill right here, when we type in bill on the brain data, what happens is that since we don't have the hardware, it finds Bill's brain data on the folder that I had shown you earlier, and it sends it to the server. And how it does that is that it uses a piece of code called check user. And so basically all this does is that it allows a person to upload a file to a specific area. So we uploaded it to a directory called check this user, and so it's in our BraiNet folder, and there it'll be stored here as user brain data, and this is how we'll compare. So that's how it's stored. And so now we need a way to query the data, right? So over here, so let's say I put in bill for user ID. So bill, the string bill gets sent to the server, and what happens is that it gets run against this PHP method. And so what happens is that it takes in the name I gave it, bill, right? And first it checks if the bill actually exists as data on the server. If it exists, then it'll run some code, and if it doesn't exist, it'll exit out. But basically, if it exists, then we can path to that specific file. So we're basically querying for that user's brain data. And so we needed a UI for user query, right? So our UI is basically this. So when they press on this wrench, it'll bring up the settings screen. And so a user can enter in a fog address and a remote address to try to access to. So there's two of them, there's fog and there's remote. And so this is the UI that we have for users to do their, or perform their queries and such on the right servers. There's no other UI that's really needed because the server handles everything. So all the user has to do is just pick the right servers as their fog and remote addresses. And so we needed to test the database configuration and operations and show. And so a tool that I had to use was a tool called ngrok. And what this does is that it allows our Apache server to be seen outside of my firewall, and so that it can be seen from the internet. And so, for example, it's right here. So if you look at this URL, this is the URL of the ngrok where it's forwarding my port, basically. And that URL is right here as well. This line right here. And so, and at the very bottom, it keeps a history of everything that is running. And so this is how I tested the database, was that first I made sure that everything was running and everything was being operated. So let's go back to the phone app real quick. So I type in Bill again, and I type in Bill, and I log in, and the current time is 12:45 a.m. on my phone. And so right here, it just performed 2 actions just now, check user and verify user. It's still trying to do verify user. And I got the 200 code. So let's see what happened. So when I go to my server and I go to check this user, I can see that this file was uploaded on today, the 30th at 12:45 a.m., which is the time on my phone. And so I know that it's correctly uploading the data, and I know that it's correctly querying the data because it ran verify user just now. So I know that my database configuration and operations work. So phase 3 was setting up a fog server and developing the algorithm to decide which one to use. So the first step was to make the fog server on the same network. So once again, the fog server was just like the remote server. It used XAMPP, it used ngrok, but the only difference is that it has a different address to get there. So in our code, we have 2 areas for that. So we have these 2 strings right here that represent the 2 addresses that a user would give to the phone. So for now, these are the 2 default addresses, but a user can easily change the addresses on the settings of the application. Okay. So we needed to implement a recognition algorithm in the fog server. And so what we actually did was that we actually went to the impact lab and we had collected the specific algorithms. So there's one called feature extract, and these are MATLAB scripts. And so this is the Kusha's code. And so that was feature extraction. This is the comparator. And so the feature extractor extracts the feature from a person's brainwave data, as the brainwave data is just a series of numbers. And the comparator compares 2 sets of features and checks to see if they're similar or not. And so in my implementation, I basically only had to change a few things as his implementation worked just fine. So here's my feature extractor. So the only difference was that my signal length is only 120 seconds and the sampling rate in hertz is 160 hertz. And these are the numbers based off of the data that was given to me. So I basically used the same exact algorithm and only had to change a few parameters to get it actually working. And so so that's step 2. Step 3 is setting the phone, the battery level and network delay. So in this code, to detect the battery level, I have a string. It's empty and it's called battery level. Then I have a broadcast receiver, and what happens is that it creates an intent where it's trying to find the battery manager's battery level, and then I can get the value out of the level and turn it into a string and add a % sign to it and put it to the battery level. And then in the onCreate method of this specific view, I can register this listener right here, and it'll help me know what the battery level is. And then to get the network delay, I have a method called get latency. And so what happens is that it takes a server's address and right here, and first it checks if it's reachable. That's its first step, and then it checks if it's how long it takes to get to it, basically. So first, I keep track of the time before I ping the server, and then I make the ping, and it has 3 seconds to respond, and then I return a long that is the current time after it receives its response, minus the time that before response, and it returns it. So that's how I sense the network delay. And then I need to run an algorithm in the smartphone to determine whether to use fog or remote. So on this part, I have a method called string or decide server. It takes in 2 addresses, IP1 and IP1, or IP0 and IP1, which represents the fog and remote server addresses, and then it returns a string. So when I go to the code for decide server, what happens here is that it basically pings both of the fog server and the remote server, and then it gets the result of the time it took to ping both of them, and at the very end it returns the string of the one that took the least amount of time. So if the fog's latency was less than the remote one, then it will return the fog latency, and then it'll take that string and it'll put it into a string best server. And then so the next part is end-to-end implementation of the recommendation of the algorithm. So since so now we have the string of the server that has the best time for everything to be run, because there's lots of data to be processed. So it takes this string best server and it uses it as an address to be put elsewhere where methods need to be called. So we have a right here we have we want to execute we want to upload the data, so we have it, we pass in best server here, and we also want to validate the user at a certain address, so we put in best server here. And also to backtrack a little bit, but besides our MATLAB code, we actually used a Python code actually. And so this Python code is called comparer. And so what happens in this comparer is that it gets the 2 brain data files to check, and then it reads them in, and it turns them to actual arrays. And then I start a MATLAB engine, and I put those arrays into I make them MATLAB compatible, and then all I do is I add a path to my MATLAB scripts folder on my server, and then I call my methods, which I showed earlier, which are feature extraction, and then once I get the 2 sets of features, I call the comparator on both sets of features, and then based on the results, if it returns me 1, that means it's true, but if it returns me anything else, it means it's false, which means that the 2 sets of data do not align, and so the user is not successfully authenticated. And this code is called from the PHP code right here. So I make a string called PyScript, and it calls it comparator Python, and it gives it the brain data of the person that their user ID is trying to be, and then it also uses the user brain data.edf, which is uploaded from the user data, this field right here, and then it runs it, and then it outputs true if they're the same here, and it outputs false if they're not the same, and then the phone will receive the response and change the final screen accordingly. So that part is for the end-to-end implementation, as well as that part is also part of the recognition algorithm and being able to implement the end-to-end implementation. And so our current team is only three people. It's currently Thong Vo, Monique Oliver, and Ragwhendra Singh, but and Professor Banerjee said we only need to do 3 of the 4 parts since we were down a member, so we did not do phase 4, and that's it.